In this figure, you see two bodies of mass m connected together by a massless rod, which is fixed at one end. This two-body system rotates as a whole in a horizontal circle on a frictionless surface. The quantities in the figure are m equals 120 grams and d equals 30 centimeters. The period of the circular motion is given to be 2.1 seconds. We are asked to determine the speed of each block in part A, to draw the free body diagram of each block in part B, and to find the tension in each cord in part C. Okay, let's answer the questions. First, we are given mass m as 120 grams, where gram is a non-SI unit. So, it has to be converted into kilograms, which is an SI unit, as 0.12 kilograms. The quantity D is given as 30 centimeters, where centimeter is a non-SI unit. So it has to be converted into meters, which is an SI unit, as 0.3 meters. And period T is given to be 2.1 seconds, which is already an SI unit. Okay, let's solve part A. Remember the discussions of tangential velocity from chapter 4. Its magnitude is the tangential speed, say v, and it is calculated by the formula v equals 2 pi times r over t, where 2 pi times r is the circumference of the circle of radius r, and capital T is the period of the uniform circular motion. Now, for simplicity, we'll label the bodies as 1 and 2 respectively. Therefore, the speed of body 1 is written to be v1 equals 2 pi times d over t, then put the numerical figures into the corresponding places as 2 pi times 0.3 meters divided by 2.1 seconds. Thus, the result is 0.89760 meters per second, which is approximately 0.898 meters per second. And the speed of body 2 is calculated by v2 equals 2 pi times 2d over t. Substitute the numerical figures into the corresponding places. 2 pi times 2 times 0.3 meters over 2.1 seconds, which turns out to be 1.7952 meters per second. And the result is approximately 1.80 meters per second. Well, these are the answers to the questions in part A, and let's solve part B. To draw the free body diagram of each block, we represent them by points. Next, the most crucial point is to draw an appropriate coordinate system, since the figure was drawn from almost a top view. But it is comfortable to look at the motion from side view, and we draw the x and y axis as follows. Therefore, the x-axis is on the surface and the y-axis is perpendicular to the surface. Hence, the gravitational forces on the bodies are drawn like this with the magnitude of m times g. Furthermore, normal forces acting on each body due to the frictionless surface are easily drawn perpendicular to the surface. Finally, the tension forces acting on each body are drawn like this, so that for the related chord and the related body, the tension force vector has a tail on the body and its direction points the chord. Also, the accelerations for each body is only the radial accelerations, and their directions are always toward the center. Notice that accelerations are not drawn just on the bodies, since only relevant external forces are drawn on the bodies. Well done. That's all about the free body diagrams of the bodies, and let's solve part C. In order to find the tensions in each chord, we have to consult the Newton's second law, which is written as F net equals m times AR, since this is a uniform circular motion and AR is the radial acceleration. For both bodies, the net force is the centripetal force, which directs toward the center. The net force on body 2 is only T2. Therefore, by the Newton's second law, we write T2 equals m times A2, where A2 is the radial acceleration of the motion of body 2. Then we have m times V2 squared over 2D. Now substitute the numerical figures into this formula as 0.12 kilograms times 1.7952 meters per second squared divided by 2 times 0.3 meters, which results in 0.64455 newtons, which is approximately 0.645 newtons. For body 1, the net force is T1 minus T2, which is equal to m times A1 by the Newton's second law. Here, A1 equals V1 squared over D. Then we have m times V1 squared over D. Then we obtain a formula for T1 as m times V1 squared over D plus T2. With the numerical figures 0.12 kilograms times 0.89760 squared over 2.3 meters plus 0.64455 newtons. As a result, we obtain approximately 0.967 newtons. Okay, we have solved all the problems. Thank you for your listening and see you in the next chapter.